this lesson, we're going to understand and identify the basic graphs of a rational function. A rational function is a function that can be written as a ratio of two polynomials. Rational functions that are written in the form of f of x equals p of x over q of x, where both p of x and q of x are polynomials with q of x not equal to 0. Here are some examples of rational functions. The graph of a rational function is a hyperbola which consists of two or more separate branches. Now the lines that the graph of a rational function approaches but never touch is called the asymptotes. Notice in the three examples here of a rational function that the hot pink dashed lines you see are the asymptotes. So your graph simply gets close to it, kind of hugs up against it, but never quite touches the line in each case. Now these asymptotes, they can be vertical, horizontal, or slant, or what we also call oblique. They simply act as a boundary for the graph of a rational function. Okay, so here we have the reciprocal function, f of x equals 1 over x, which is the basic or the parent of rational functions. Let's go ahead and plug in some values into this function so we can get an idea of what it looks like. Let's start with a -2. If we remove the x, replace it with -2, you can see we're going to get an output there of -1/2. If we plug in a -1, that's going to give us an output of -1. If we plug in a -1/2, 1 divided by -1/2 is going to give us -2. If we plug in a 0, you know that when you have a 0 in the denominator, that it is undefined. Let's go ahead and plug in 1/2. Plug in 1/2. 1 divided by 1/2 equals 2. Plugging in a 1 is going to give us an output of a 1. And lastly, let's plug in a 2. If we plug in a 2, we get an output of 1/2. Okay, so we have our points. Let's go ahead on the next page and plot them on the rectangular coordinate system. Okay, so this is what it looks like once we plot the points. And now all we have to do is connect those points, and there we have a graph of the reciprocal function. Notice that since it is undefined at 0, you'll notice that on the x-axis as well as the y-axis, that our graph will never touch at that point of x equals 0 or at y equals 0. And so what we're going to have there is what we call an asymptote, which we will discuss later. F of x equals 1 over x is the parent function of rational functions. This particular function, you will always see that you will have two branches here. One will be in quadrant 1, while the other will be in quadrant 3. And taking a look at this graph, the end behavior, as x approaches negative infinity, so in other words, as your x values approaches negative infinity, the function approaches 0. It approaches 0, but never quite get there. Like I say, it kind of hugs up against it. And then on the other end there, as x approaches 0 from the left, the function approaches negative infinity. On the top there, here, as x approaches 0 from the right, the function approaches positive infinity. And as x approaches positive infinity, the function approaches 0. So it gets close there, but not quite touched there at 0. So that's the end behavior. What about the vertical asymptote? So do you see vertically a boundary line, a point to where the graph does not touch but get really close to? Well, if you said right at 0, x equals 0, then that would be correct because that is your vertical asymptote. And again, the graph will never cross that. The asymptote is a boundary there. It acts as that boundary. It sort of gets close, our graph, to that, but never quite touches or passes through it. So yes, we have a vertical asymptote at x equals 0. What about a horizontal asymptote? So a point on y to where it does not touch the graph at all. And yes, it is going to be at y equals 0. That is your horizontal line there that the graph will never touch, get close to, but never touch. So we have a vertical asymptote again at x equals 0, and we have a horizontal asymptote at y equals 0. And this is the basic of your parent function of rational functions. Another basic rational function is f of x equals 1 over x squared. So the bottom is squared. And notice that if you look at the graph, you see two branches both kind of facing upward. They're both sitting up. So let's take a look at that end behavior of this particular rational function. So as x approaches negative infinity, the function approaches 0. And then as x approaches 0 from the left, so as x approaches 0 from the left, the function approaches positive infinity. And as x approaches 0 from the right, the function approaches positive infinity as well. And as x approaches positive infinity, the function approaches, gets close to 0, but not quite at 0. What about the vertical asymptotes of this graph? Do you see a point where the graph does not touch on any x value? That's correct. That one is also at 0. So x equals 0 is my vertical asymptote. And what about our horizontal? As you can see, it hugs the x-axis but not cross there. So the boundary point is also going to be right there at y equals 0, just as in the other graph. Which graph has x equals 2 and y equals 0 as the asymptotes? Feel free to pause the video while you think about it, and when you're ready to reveal the answer, restart the video. Okay, so what did you select? Well, we're looking for a graph that has x equals 2. In other words, a vertical line passing through the x-axis at 2. So let's look at choice A. Yes, you do have a asymptote there. Choice B also has an asymptote at 2. Choice C has an asymptote as 2 as well. And so does choice D. They all have it. Okay, so then it's going to have to be the y equals 0 that's going to be the deciding factor. We are looking for a horizontal line passing through y at 0. That does not occur on graph A. You don't see a horizontal line there through the asymptote there. Neither B. But at C, it does look like we do have a horizontal line there at 0. So again, choice C would be the choice because it has a vertical line passing through the x-axis at 2, and it has a horizontal line passing through the y-axis at 0. So therefore, it is choice C. Okay, so which graph has x equals 3 and y equals -2 as the asymptote? Feel free to pause the video. When you're ready to reveal the answer, go ahead and restart the video. Okay, so which answer did you choose? We are looking for a vertical line passing through the x-axis at 3 and a horizontal line passing through the y-axis at -2. And if you said choice B, that is correct. Okay, good job. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.